My name is Joe Vigil, and got my team here, Jeremy Pfeiffer and Nick Lujan. Jeremy is with our tech support group, and Nick is with our digital team. We embarked on a project, I would say a year ago, on how do we basically gather data from the field that we can use to be able to make a difference on how we troubleshoot and how we affect our future designs. So this project has, this presentation has a little bit to do about that, and also historically what did we do and where we're going to go in the future. So really it all has to do about data, and I think by now everybody's pretty much got the theme of things. So data comes in many different forms and fashions. Obviously, we have the stuff we write down. A lot of that is CIP records. There's a lot of laboratory records that people pick up from their laboratory results. And then there's data that we collect in our systems, like our SCADA systems that have data loggers and things like that. That come from instrumentation, and then of course there's alarm systems and logbooks and all that stuff. So we want to be able to find a place to put all this stuff, because ultimately this lands up in different places. So it's a lot of data. It's not a little bit of data, it's a lot of data, and it's a lot of data hard to find. So as you can see here, there's some estimates about, let's say, for a regular wastewater facility. There's generally 99 different kinds of tags that are being monitored on the SCADA system. Many points per day and annually. It could turn into 29 gigs per year worth of data that just comes out of one small plant. And then you probably ask yourself, well, why so much data? Well, because everything is being monitored, everything is being logged, everything is being monitored. So you put all that together, I mean, it turns into a huge amount of data. But the issue here is, what do you do with it? You can gather this data, but it's got to be in a place we can do something with. And when you put it all together, it looks something like that. And of course, when we are intimidated a little bit about some of these kind of things. So what do we do when we have too much data? So in 2013, we, Ovivo, introduced the Fishbone concept for membrane systems. And actually, since 2001, since we first started, we collected a bunch of data. It's been terabytes of data. Thousands and thousands of static field service reports. Lots of good information that our people picked up in the field about how things work, what the issues were, how did they correct things. And it's there, but it's buried in some system somewhere. Literally gigabytes of data. So what we need to do is we need to come up with a platform that we can be able to get this information, use the cloud, which is something that I think a lot of you are now familiar with and what it can do for us. And we needed a method to do it, and we also, amongst ourselves, and we need you to help us. So, like I said earlier, that the Fishbone, it really isn't dead. I think we started off and said it was dead. It's static, meaning that here's an example of a particular failure. In this case, let's say a centrifugal pump of some sort, the capacity is not right. It could be from various different things, suction, speed, feedback loop, discharge issues, the like. But this is a static thing. In other words, if you have this problem, if you have a centrifugal pump problem, you say, well, okay, I'll look at my Fishbone and I'll say, maybe the first thing I go look is, do we have a leak? So I look on the Fishbone and yeah, there it is under the suction section. I better go check all the leaks. And, oh, no leaks. Okay, what's the next thing I go look at? Maybe the wiring. Well, it wasn't that either. So how do we get to the more high probable issues quickly? Well, first of all, if we have a way to gather the data, we can start to categorize, like, for example, when we had a centrifugal pump problem, and we were monitoring this real time, and we were putting the information into the system will tell us that 33% of the time, it was a leak. So that's the first thing to go look for, okay? Maybe the second thing to go look for is something wrong with the design. The total dynamic head wasn't accounted for, or in total accounted for. That's something to go look for right away. So that would be the very next thing we look at. So in essence, by doing the work in the field and inputting into the system, we're able to develop what we would call a dynamic system now. Okay, we're looking at, okay, we had this problem, this was the resolution, this was what we thought it was centrifugal pump capacity, and then we resolved it to be either a leak or any one of these items on here, and we log that in. So the next time this happened by someone else, he does the same thing. And over time, we grow a database that says, from probabilities, what the actual, more than likely, is going to be the resolution to your problem. So we get to the resolution of the problem quicker, and we're able to then know which are our high-hitting issues. If we're always seeing leaks, obviously, let's say, for example, if the high-hitter item is the leak for this particular problem, and we've seen that 33% of them are leaks, Mr. Engineering Group, should we not be checking and seeing how we can prevent leaks in the future? What are we doing wrong so that we don't have leaks? So that's the idea behind this. So if we can accumulate this data and put it into a database that then we can now take out of the database as to what it is that we're going after, at the same time helping our people in the field actually deliver on fixing a problem quicker, faster, and more inexpensively. So therein lies what the very next step happens, is as we gather the data, then we can have the system tell us by occurrence what were the most important things. So in this case, you know, we categorized them in different ways. I mean, this is just an example, so that we can discretize the observations and the root causes, and we can connect them together and determine what's our plan of action, not only from the standpoint of what do we do from a design standpoint, but at the same time in the field, as we work in the issues, what are the first things to go after? At the same time, we also gather the data real time, what's going on, so over time, these charts may change. They may say, for example, in this first one, it says the top occurrences were process. Well, maybe in a year from now, it might be a different thing. It may be mechanical issues were the number one issue. And it depends on how we address these Pareto items. So with that, I'm going to turn this over to our team over here to tell you a little bit about the mechanics of it and how it works.
So I'm part of the digital team, and we were tasked with trying to create a system or a tool that we could get the observations. So we get a call saying, hey, we have this problem, to a resolution or a root cause. What do we do to fix the problem? What caused the problem? And how do we make it so that problem doesn't happen again? Or we improve the operation so you have less downtime. The step one is to standardize the names. So when we get a call, we're going to get some generic thing that says, hey, our membrane's ragging, or the level's going high. We need a way to standardize so we can group what the observation is and draw a line to the root cause. You'll see the controls, electrical, external conditions. These are observations that we can group. So that way when you call in and say, hey, I got an alert going on my panel, it says high level, we can easily go to a drop down and say, hey, this is what it is, this is the problem, and we can tie that observed issue, that observed category, to the root cause and the resolution. In our system, we have tools that you'll see the Fishbone that we had in the previous slides. That'll show you the percentages. What's the common solution to a problem that you see?
Basically, where we're trying to tie in is taking and tying together all of the territories throughout the country, because if you're only working at the same plant every day, you're not as likely to have as large of a sample size as, say, the entire country. So when you have a common reoccurring issues throughout the country, you can tie that together and help reduce troubleshooting time. In essence, is what your end goal is reducing the amount of time it takes to solve problems. And what we're doing is combining basically troubleshooting steps throughout the country in one database, and we're taking historical data. So we have years and years of trouble calls that have come in to our tech support, and we're able to manage a database to say, when this problem arose, this was the root cause, and as those root causes became built up a common database and a similar collection of similar root causes, this is our customer relations management tool that we use to combine all of those cases throughout the country and throughout all the plants. So here is a snapshot of the CRM tool itself. So in this example, I'm going to go through a couple examples of a trouble call that comes into our center, how we're going about identifying problems that come in, and how we're taking that problem and using it to fill a database that can help reduce troubleshooting time in the future. So this specific example is a pump that's having loud noises coming from the pump itself, and they're not exactly sure why that's happening, but say they have two pumps, and it's happening to both pumps. So what we'll do is we'll take a case that comes in, and back on this slide, when the call comes in, we're able to use our database to pre-populate the site information so that when the case comes in, we have all of the information of that plant populated, and it shows the observed category that came in. So on this specific case, we have an observed category that is a high turbidity alarm. Actually, this is a different case than the pump issue. But basically what we're showing is that right when you open it, over to the right, there's some troubleshooting tips that were pre-populated from past cases on items to check. And what we're going to eventually do is tie these issues back into the specific product that the issue happened to. So on this one, microblocks unit, there's high turbidity, and those are items you can check throughout, is the flow through the turbidity analyzer, if there's a local alarm at that analyzer, that the light itself that most of them work off of is still lit, and you want to look for air that might get caught up in the analyzer. So this one, so let's say air made its way and entrained itself into the turbidity analyzer. You wanted to find not just a way to reduce the air, but you wanted to find the root cause of why the air was making its way into the analyzer to begin with. And in this case, a solenoid was leaking by, allowing air to get into the permeate line, and the turbidity analyzer samples from the permeate line and made its way into the analyzer. So this solenoid we would have replaced with an actuated valve that's more airtight, doesn't run the risk of allowing air to intrude into the piece of equipment. So that is the first example there. What we have here is tying back to the Fishbone for an erratic flow meter. On this example, we're making an example on this one. Let's say you had your flow meter in the reverse direction. Usually they're pre-stamped with arrows that tell you which way the flow should be going to accurately read the flow on this flow transmitter. And on this flow meter here, what the end user is seeing in the HMI is a is a flow deviation alarm. So when the flow is not reaching its set point, it's going to alert that alarm. But the only call you're going to observe might be a flow deviation alarm. And when you wind up drilling down to the root cause, and you find that the flow meter was, let's say in this case, improperly installed. What we want to do is combine that root cause and combine that issue all throughout the country, anyone else that may have had this similar issue, and get visibility to that. So what we can do is feed back to plants, say, hey, if everyone's Hawk flow meters are being installed backwardly, how can we improve the installation procedure to prevent this from happening in the future? So this was just an example of where when we're getting our call in, we have quick reference to the Fishbone because it's not dead, it's just static, and it's something we can build off of. So now what we've done is when we find root causes, this is where the tie-in comes into play with tying together all the data that comes in from around the country to gain better visibility on issues that are happening out there to identify common root causes. I think, Joe, you can.
Okay, and so to put the last piece of this together, essentially all this data that we collect, and not only the data that Jeremy and Nick showed you, as they went through going through a specific issue problem in the field, but also data that we maybe have collected from operators that was input into the system. We can come up with very detailed analysis, pie charts, telling us what were the major issues, mechanical controls, process, et cetera, and what percentages, what were the actual open jobs and which ones are closed. This is an example of some recent data that was downloaded recently, and just so that to give you an idea of the analysis that we can do. We also took a look at some historical data way back, like I said earlier, that this data gathering started in 2001. I looked back to see also like what were the big hitters. Were the equipment failures, or were they process failures? What were the root causes of the mechanical issues and the root causes of control issues? And then the Pareto items, top 10 items of failures. With this information, then we can take concrete actions to correct our designs, correct our way we operate, correct issues that we see on a normal basis. So with that, I would just like to say that what we call this is the Failure Reporting and Corrective Action System. For those that are interested, this is a very common acronym that's found in most industries where they're trying to make a difference when it comes to reliability. You can look this up in the web and get more information on it. But this is Ovivo's idea and form of the Failure Reporting and Corrective Action System. And thank you very much. Yeah.
Thank you, guys. Sit down. Any questions? Yeah.
Yes. Richie Blackmore, David Gilmore.
Right country, wrong guitarist. Any else? Oh, come on. I'll tell you what, I do actually have a question which doesn't concern English rock guitarists, if that's okay with everyone.
Sure.
So you've basically got this root cause analysis thing. Do you have a measure of what kind of closure rates you have? So is it like every single thing that arises in every single location is addressed within a certain space of time?
Yes, every site has their particular data aggregated for their site. And when a case is opened, it shows that it's open or what the status is of the case. And so we can see whether they're open or closed or in process or whatever per site.
Right, okay.
As well as the aggregate of all sites.
So my next obvious question is, how long does it take you to sort of, do you have like an average time for for addressing
Well, the
particular
system is
issues?
still very much in its infancy, so
Oh,
we're
okay.
still kind of rolling things out. I don't know if you noticed on that first analysis chart that I showed you there, there were like 50 cases that we have so far. So it's very, very early on.
Right.
But as we roll out our new plants and our new sites and our even existing sites, the capability that has to be put in so that we can download this data into the system.
Yeah, and the more data you have, then
Yeah.
the more obvious it is as to what,
Right.
as you've pointed out yourself, you're going to have certain types of events which will lead to certain types of rectifications, and you just apply the same rectification whenever you have the same type of error. This kind of proactive thing which Dennis talked about yesterday, which looks pretty good to me, to be honest. Any other questions? Yes, sir.
You talk about step one in standardizing nomenclature. Do you have an established way of disseminating that information to various operators and technicians so that they know what you're saying, you know what they're saying?
Directly to the operator, not as of yet. We have this standard, we call them attributes, that are in the system. So when our field service tech support person goes there, he has to pick one of those categories. So essentially, he'll pick up enough information from you as to what the issue is, pick the category, and then work it against that particular category.
Those, the names of those have been from previous calls that we've had in the past. Dennis had created a list from those cases, a huge list of cases, and kind of created those general categories from those previous cases. So they should be pretty closely tied to what's happened in the past.
That was a few years worth of
Yeah.
cases, yeah.
And I actually agree with him. If, with time, when our guys are starting to ask those questions, I think that language would translate to them, knowing that this is what you're looking for.
Yeah, so
Eventually, let's say 2 years from now, you would have all described the same issue exactly the same way.
yes, and what's good about it is what you can do is retroactively go back to that case, like as the case is observed and it's described when you say call the hotline and you call in your problem. It's not set in stone that this observed category is there. Once you get to the root cause, you can manipulate that original observed issue in a more standardized way. So you have common traits to common problems, and you standardize how you categorize them.
There is
Okay. Sorry.
At the moment, this is an internal system that we manage our work with. But I was just going to say that in the future, we do see rolling out where it's when you want to make a call, you can get on the system through Water Expert, let's say, and say, this is my problem, and this is what I think it is, and this is the category that I think it is, and that will then download into this system, and or it's all part of the same system, but it'll be there for.
We are looking at building a form that will have those kind of same drop-down options for external.
Yeah.
Which will be on the water expert. So just to be clear, CRM is our way of communicating, and the water expert is a copy of the CRM. So that's what we're saying. So when you go to the knowledge center, you will see what we're doing with water expert. It's uploaded from the CRM. Your charts and everything you see is from the CRM. They're saying this works very well, and it's back to you guys. We can also push that to the water experts so you can see it. But to your comment though, Dr. Judd, I think he had like 10 cases when we first started, and he's down to 1 case.
Right.
So he actually solved quite a few.
Yeah, it's quite a good closure rate.
A lot more efficient. I think we already are seeing the benefits of it. But it is pretty early. We only did this like, what, 3 months ago, 2
Yeah.
months ago?
All right, right.
Yeah, it's very
Well,
beginning.
yeah, this is something that we've been doing for a long time. It's just gathering that data. We're just kind of putting it in a way that we can start connecting the dots a little more easily. The system can do that for us rather than having to go through each case line by line. It's kind of the nice thing about automation.
It's not dead, it's just live. Right? That's what we did. Dynamic, it's dynamic. That's the word.
dynamic. That's
Yeah,
a
so
good
for
word.
for our individual tech support people, if, for example, if Jeremy's working on a particular project and he's got 5 or 6 different items open, he can manage his workload through that and say, well, I've got 5, I finished 2 today, I've got 3 left to go. At the same time, his boss and others that are interested in the management of this particular project, they can see what the status is at any given time.
No, it's all cool. But I think on that note,